Hello friends, here in this video we'll see a problem on sectional orthographic projections. For that, here is the question. It is given that figure below shows pictorial view of an object. Draw using enlarging scale, that is 2:1, the following views. It means we have to make the dimensions double because it is 2:1 scale. Sectional front view along AA looking in direction of arrow P. So this arrow P is the direction for the front view, and then sectional top view along section BB. So this BB is nothing but the cutting plane, and then left hand side view. This is the direction for LHSP, the left hand side view. Now, when we start this question, we should know how much is the total length, height and width, and that too we'll have to make it double. So first I'll calculate the total length. Length is seen in the front view, and if I see here from one end to the center, it is 33 mm, and next from this center up to the center here, it is 17. So 33 plus 17, that gives me 50 mm, and then from this center to the outer radius, which is 8 mm, so that gives me 58 mm as the total length. Now that 58 mm I have to make double because this problem is of enlarging scale, that is making all the dimensions double. So length, if it is 58, that will become 116, that is twice of 58. Then for the height, here it is 30 plus 25, which is 55 mm, and as I can see here there is a minor gap, as we see a slight curved surface. So I can also say that instead of 30, if I take 33, then I'll reach up to the center, then from the center up to the top it is 25 mm. So 33 plus 25, that is also 58 mm. So height is also 116, and then for the total width, here this is 17.5 plus 17.5, that is 35 mm, and when I make it double, that will become 70 mm as the total width. Now once the total height and width are known, I'll explain the spacing for this problem, and since the method is not mentioned, we are going to use first angle method of projection. Here, as we have to draw left hand side view, and by first angle method of projection, left hand side view should be drawn on right hand side, that is in VP, and it means if the side view is on right, front view should be on left, and in the front the length and height are visible. So I'll draw a square here of length 116, and even the height is same. Then below the front view there will be top view, and from the top the height is not visible. Length and width are visible. Length is 116, that I'll project it down. Width is 70 mm. Then for the side view, here I am drawing a 45-degree line. Looking from the side, the height and width are visible. Height I'll get it from the front view, width from the top view. Now inside this rectangle I'll draw the side view. So here will be front view, over here top view, and over this side view. Now and then here when we are starting with the front view, whenever it is given that you have to draw sectional orthographic projection, that is the question is based on sectional views, then draw it plain first, that is without taking the section. Complete all the views and then go for the section, that is cutting the object. Now when I am looking from front, in that case the first thing which is visible to me are these surfaces. Now here I look at the center, it is 33 mm from right hand side and 33 mm above. It means when I double the scale, it will be 66 and 66. So measuring 66 from one side, 66 from the other side. So here if we see, the outer circle is having diameter of 25 and inner circle is diameter 16. So I'll start with the outer circle. Diameter is 25 and we have to double the scale, so that will be 50 so radius becomes 25 Drawing a light circle from here. Inside this there is another circle of diameter 16, which I'll double, so it becomes the diameter 32. So the radius will be 16. Drawing it light. Then here there is a cut of 3 as we see here there is a gap, so that will become 6 for us because it is double, and measuring 3 on both sides. Then there are these heights of 5 these surfaces would be visible, so that will become 10 for us. So measuring 10 on one side, 10 on the other side, drawing light horizontal lines. Because these two lines are touching the circle, like here. Next, looking from front, even this portion, this rectangle is visible. So from the center, here if I see its total length is 12, so this will become 24 for us, and it is measured from the center. So from the center, I'll take 12 on both sides. Then after that, here there is a portion having radius 12 so that will become 24 for us, and for that it is a quarter circle. So here I'll measure the radius 24. drawing it light, projecting it light. This distance is 42 mm, that is double the scale, and exactly here it is 21. So we have reached up till here. Then in that case, there are two holes inside these plates of diameter 6. So we'll make it as 12. Locating its center, radius 8 mm. So for us, it will be radius 16 mm. So I'll measure 16. The circles are having diameter 6, so for us it will be 12 mm, measuring 6 mm on both sides. So there will be holes inside these two plates. Then even at the top here there is a hole of diameter 6. So that will become 12 for us, and it is 12 mm deep. So for us it will be 24 mm deep, that is double. So from this center I'll measure 6 mm on both sides. Measuring 24 mm. And that is a tapped hole, so it will be drawn in this way, or we can say that is the hole which is being drilled. Next, after completing up till here I'll draw a slight curve joining both of them, both these surfaces, drawing it freehand as the radius is not given, and it will be up till here. Now here I can say that the front view has been completed. I have drawn it light because we have to take the section, so I will make it dark later. So after completing the front view, which is a plain front view, I have drawn it light. Finally afterwards I am going to make it dark. Then moving on to the top view, and this is the direction for the top view. We are standing here as an observer. Now looking from top, the first thing which is visible to me is this surface. Now this surface is having width of 25. Its length is already there in the front view. Now that width 25 will become twice because the scale is 2:1 in this problem. So width will be 50 mm. I am projecting the length first from the front view. Then here the width of this portion is 50 mm, and when I'm looking from top, in that case, about the center line the object is symmetric. So first I'll take the center here into the top view, that is taking half of the width. Now from this center line I'll measure 25 mm on one side, 25 on the other side. So this is the rectangle visible from top. Then inside that we have a circle of diameter 6. So this will be for of diameter 12 because of the scale. So here that circle, its radius we already have in the front view. I'll project it down. Now this circle will be visible from top. Then at the same time, here there are these surfaces, semicircular surfaces which are visible from the top. So it is exactly at the center, and its center in the front view is already there with us. So I'll project that line into the top view. Then this is the center, and here is the radius. Then the length of this portion where it is extended into the cylinder, I'll get it from the front view. Then after that, there is a hole inside this plate of diameter 6. It means that will be of diameter 12 for us. Its radius is there already in the front view. I'll project it down. getting this circle. Then looking from top, in that case, this cylindrical surface is also seen. It will be seen as a rectangle, so projecting it. And whatever remains is this rectangular surface. Now, after reaching up till here, there is a hole inside this cylinder. That hole will not be visible from top, so it has to be hidden. So, projecting it down. Similarly, onto the other side. Then, looking from top, in that case, here there is a width which is not visible from the top, so this line will be hidden. Then after that, here I leave the top view as it is because we have to draw both the front view and top view as sectional. So leaving it as it is, going on to the side view. Now looking from the left hand side, first thing which is visible to me is this plate, and a similar plate is there below it with a gap of 3 mm. So I'll project their heights from the front view, and width I'll get it from the top view. And at the same time, when I am looking at this plate from side, about the center line the object is completely symmetric, so I'll project the center line from the top view into the side view. Getting the heights of the plate. So getting the heights of the plate, then their width, I'll get it from the top view. So there are these two plates, then looking from side, in that case this surface is also visible. So its height I'll get it from the front view and width from the top view, that is the rectangular surface. Width is 50 mm. I'm projecting from the top view. So this is the width. Next, here if we see in this question, it has been said that we have to draw the left hand side view. Now this left hand side view is not sectional, so you can directly make it dark in order to avoid any kind of confusion here. So here I'll start making it dark step by step. Starting with this rectangle at the top. Then the cut is there throughout. Next, the plates which are there. it will be seen from the side view. Then projecting this cylinder, because from the side the cylinder is also seen, so it will be seen as a rectangle, getting its height from the front view. Cylinder is there throughout the width, if we see here, so it will be made dark. So here there is a gap throughout, if we see into the diagram, so that gap will be seen, and whatever is there at the top and at the bottom, that is the part of the cylinder. Here there will be this dark line because from this gap, here this circular surface will be visible as a line, so that line I have drawn. Then the part of the cylinder which goes inside this rectangular surface will be hidden, because this cylindrical line, this surface is there throughout the width. So for that purpose, I'll make it hidden. Next, after this, whatever is left at the bottom of the cylinder, that will be seen as a rectangular surface. So this complete surface will be visible as a rectangle of width which is there throughout. So there is dark line between both these surfaces, because the cylindrical surface and this bottom rectangle, cylindrical surface is extended, it is ahead, bottom rectangle is behind, so there is change of plane and it is indicated with the help of a dark line. Then after this, inside this cylinder there is a circle which won't be seen from the left hand side, means it has to be hidden. So for that, I'll get its height from the front view, and width is there throughout. So this will be hidden. Next, looking from the side, there is a circle of diameter 6. For us, it will be 12 because of the scale 2 is to 1. That 12 diameter circle is there in both the plates. So I'll get that circle from the top view. Drawing the center lines. Then, when reaching up till here, I can say that even inside this rectangular surface, there is a hole which will not be visible from the side, so it has to be hidden. So, getting this hole, it is onto the same level because both the holes are having the same diameter, which is 12 So, it will be projected up to the cylindrical, or I can say here it is a rectangular surface. This hole will be hidden. I'll draw it in this way since it is a drilled hole. So here I can say that the side view is being completed. Now going for the sectional front view, and section is along AA, means this is the line about which the object is cut. So when the object is cut about this line, it will look like this, because this is an added diagram which is given here. This is for the sectional front view. And remember, this is not a part of a question. Our question is only up till this much. This diagram is given so that we can visualize, we can imagine how the sectional front view is going to look like. So here when this line is cutting this given object, that is the given pictorial object, so after cutting it, it is divided into two halves. So the portion which is in front of us in the front view, this will be removed, and then when we are removing this part, whatever remains is here, and this is what we have to draw. So here I can say that first this rectangle is being cut, and inside that there is a circular hole which is 12 mm deep. So when it gets cut, it will look like this, because that is a drilled hole. Then the rectangular surface and this cylindrical surface both will coincide, because all the surfaces are going to be there onto the same plane. When we are drawing the plane front view, this rectangular portion, cylindrical portion, they are on different planes, but when the cutting plane passes through them, they come onto the same plane like this, which has been shown here. So I have to draw this sectional front view, and for that, remember, first make the outlines dark, then only go for the internal details. So here first I'll draw the outline of the drawing dark. So these are the outlines. Then when the object is getting cut, in that case there is a gap. This gap will remain as it is, that is, it will reach up to the inner surface of the cylinder. So I am extending this gap. Then the inner circle will be made dark. Then as these two circles are being cut, so it will look like this, that is, the surface will appear as rectangle. So drawing vertical lines through them. So here is the portion inside which there should be sectioning. So I would be just shading this surface to show you all that where we should do the sectioning. So here I am shading this surface which will be the sectional front view. So within this shaded region, there will be section lines, and section lines should be inclined at 45 degree. So here within this region, we can select any point, and with the help of that, I'll measure 45 degree, and then drawing the section lines. First, I'll draw them light. Lines inclined at 45 degree. These are the section lines which should be shown when the surface is cut. That is, whenever we are drawing the sectional view, we have to draw these lines as an indication. So these are the section lines. I have drawn them light. Next, I'll make them medium dark because section lines should be lighter than the outline. For outline, I have used black, and for medium dark lines, I'll use red. So here is the sectional front view. Then I'll just draw the center lines here. Then after completing the sectional front view, here even we have to draw the sectional top view, and that is along BB. So this is the section, means here is the cutting plane which is passing through this gap, and about this line. So this line is going to cut the object, and when we are looking from top, the part which is in front of me, that has to be replaced, and whatever is remained, that I'm going to draw. Now when I see here, when the cutting plane is passing through this gap, here the plate is retained, it remains as it is not being cut. So this plate will be made dark. Next, this cylindrical portion is cut, means there will be sectioning only inside this thickness, and the remaining part, that is this rectangle, is also not being cut because the cutting plane is above this rectangle. If we see here, there is a gap, so only sectioning will be there inside this portion, and this top rectangle is being removed. So here I'll first draw the outlines. So there will be sectioning only inside this portion. Here I am just shading it. And the sectioning lines are inclined at 45 degree, so I'll just draw parallel lines. And then this top rectangular surface has been removed, and the sectioning is there only up to this part. So this will be the sectional top view, and here I'll say that only the dimensioning part is being left, and I'll locate the cutting plane as well. This is section plane AA. Section plane BB. Then finally I am going to give the dimensions here, and this problem was of scale 2:1. So here when I'm giving the dimensions, I'll give the original dimensions here, although I've drawn it with double the scale. These are the plates. Then this rectangle is having length of 12, and then this hole diameter 6 and 12 mm deep. Inner circle is having diameter of 16 mm and the outer circle. So giving the dimensions here. This outer circle is having diameter 25 mm. Next, here the center is located at 33 mm distance from bottom. Thirty-three mm and then 25 mm. Next, from here also the location of the center is 33 mm. Then after this I'll give the dimensions in the top view. The circle is having diameter 6. Outer semicircle having radius of 8 mm. And here the total width is of 35 mm as per the dimensions given. Total length is 58 mm. And then coming to the side view, This gap is of 3 mm. Five mm height plates, then here in case of front view, the one of the dimension was left, that is this radius. It was 12 mm. Now here the width is 25 mm. And the total width is 35. Then I'll give the total height here. .58 mm. This is the sectional front view. Sectional top view. And this is left hand side view drawn towards right by first angle method of projection. And with this, the problem gets completed.